Let's discuss what is a transformer. Transformer is a static device which is used for transforming AC electrical power of one circuit into AC electrical power of the same frequency in another circuit. Simply, transformer is a static device which is used for transforming AC electrical power of one circuit into AC electrical power of the same frequency in another circuit, and it can raise or lower the voltage levels, but with corresponding decrease or increase in current levels. Let's analyze this statement. If suppose this is the one circuit and let us suppose this is the another circuit, and these circuits are magnetically coupled. There is no electrical connection between this circuit and this circuit, but these two are magnetically coupled. Let us suppose this is the AC electrical energy input given to this circuit. Now according to this statement, transformer will transform this AC electrical energy input of this circuit into AC electrical energy of the same frequency in the another circuit. So this is what we call it as transformer, and the side of transformer at which source is applied is called primary winding of the transformer, and the side of transformer at which load is connected is called secondary winding of the transformer. And please keep in mind that along with the transformation of power from one circuit to another circuit, transformer can increase or decrease the voltage levels, but with corresponding decrease or increase in current levels. Means if suppose the transformation of power from one circuit to another circuit is accomplished along with decrease in voltage levels, it can also be said that the transformation of power from one circuit to another circuit is accomplished along with increase in current levels. Simply, if primary winding is at higher voltage level and secondary winding is at lower voltage level, then according to this statement, primary winding will be at lower current level and secondary winding will be at higher current level. Now let's see the applications of transformer. The main important application of transformer is in power systems. If suppose this is the power station at which electrical power is being generated, and that generated electrical energy is being transmitted and distributed through transmission lines and distribution lines to the consumer terminals, and consumer terminals may be industrial loads or domestic loads or commercial loads, etc. The generated electrical energy is of levels 11 kV or 22 kV or 66 kV, but for transmission purpose the voltage levels are at hundreds of kilovolts. So in order to transmit that generated electrical energy at higher voltage levels, here it requires a transformer which is step up transformer, which will step up the voltage levels. And similarly at consumer terminals the voltage levels required are very less, that is it can be 11 kV or 440 volts or 220 volts or etc. So As transmission and distribution voltage levels are at higher levels, for consumer purpose those levels must be reduced to the required levels. For that, here a step down transformer is required. Therefore, power system now can be represented like this. Let us suppose this is the power station, and then this is the step up transformer, and this is the transmission line, and this is the distribution line, and now this is the step down transformer, and this is the consumer terminal. From the protection point of view, transformer can also be used as electrical isolator. That is, here this is the transformer primary winding, this is the transformer secondary winding, and these two windings are magnetically coupled. There is no electrical connection between this circuit and this circuit. Therefore, transformer also provides electrical isolation. And what is the importance of electrical isolation means? Let us suppose there is a huge fault here, and this fault, because of the electrical isolation, will not travel to the generating stations, because here coil which will behave like an inductor which will not allow sudden change. Therefore, fault will not travel to the generating station. So here generating stations equipment are protected because of electrical isolation, that is due to transformer. Next, the other important application of transformer are for electrical measurements. If suppose there is a necessity for measuring the line voltage here, as we know that these voltage levels are at higher levels which can't be measured by our normal 500 volts 100 volts measuring meters. So in order to measure those higher voltage levels, potential transformer is used. This potential transformer is connected to the line which is at higher voltage levels, and this will convert into lower voltage levels which is sufficient for the low voltage range measuring instrument. And similarly for measuring line currents which are at higher current levels with the low range ammeter, CT, that is current transformer, will provide the necessary or sufficient current which is required for the low range ammeter. And after obtaining the reading from the low range meters and by multiplying with suitable transformation ratio constant, then you can know the actual higher voltage levels or current levels values. And other application of transformer is in electronics, where here transformer voltage levels and current levels are very low.